Okay, so today we're going to learn piecewise function. So piecewise function, also called hybrid function. So it's one function defined by more than or equals to two rules. Okay, two or more rules. Okay, defined by one function. And the graph is somehow looks like that. Okay, if you can see that on your notes, it's like by different. Okay, that's one function, that's one function, that's one that's one rule, that's one rule, that's one rule. So it's three rules for the first graph. Have a look at the second graph. How many rules are there for the second graph? 3. Okay, can you see 3? Because we have a single point here. Okay, we have a single point here. Even though there's only one point, that's still a rule. So if I can write that into hybrid function format, what I can do is, okay, fx will equals to x squared. Okay, let's say that part is 2. So when x belongs to negative infinity to 2 exclusive, okay, you cannot include the 2 in. And the next rule is y equals to 6. So you write 6. X belongs to, that's a single point, which is 2. And you go the next one is 10 minus x, where x belongs to 2 to 1, 3, 4, 5, 6, that's a 6. 2 to 6 included the 6. Okay, that's the rule for this hybrid function. Okay, it's 3 separate rules and with different domains. Okay, a really common mistake, it's not really like say common, it's just some mistakes, just students can't understand what is hybrid function. So hybrid function is still a function. So then if that's a function, okay, function is 1-to-1 or many-to-1. So which means you have one x value. You can only have one y value, okay? Again, if you have one x value, you can only have one y value. Even though you have 3 rules, but for one particular x, that can only goes to one particular rule. Okay? For example, x equals to 2, can only goes to the middle one. It cannot go the first one, cannot go the bottom one, because the domain not include this 2. Okay, what we just do a test for year 12 students like at the beginning of the semester, and very surprised me is they ask you to say find the y value when x equals to 4. Okay, find the y value when x equals to 4, and actually like half of the students just put the 4 into all the functions. They write f4 equals to 16, 6, and 6. Okay, that's what they actually did, but it's not right. Okay, it's not right. This is a really bad mistake, because if you do that, 1x has 2 corresponding y values now. Okay, if that's a function, 1x cannot have more than 1 corresponding y values, then it's not a function anymore. So that's a really bad mistake here. So when x equals to 2, x equals to 4, it can fit in this domain. Okay, it can fit in this domain. So f4 will only equals to 10 minus 4, which equals to 6. Okay, for each x can only put in one rule, and that only give you one value. Okay, I haven't really emphasized that for last year students, and they make this mistake. So I changed it this year. I really want to emphasize that at the beginning. So make sure you substitute x value. Look for the domain. Which domain is actually satisfied? And I put that into that rule. Okay? Do not put in all the rules. It's not going to work. Okay. So that's the idea of hybrid function. You just have separate rules and you draw things within the domain, and that is one count as one single function. Let's say we have the open circle here. We have the open circle here, we have the open circle here, which means when x equals to 2, this function cannot take x equals to 2, and that function cannot take x equals to 2 as well. So for a hybrid function, each x value can only occur once. Say, for example, if we have fx equals to x squared equals to x cubed, for that one is x belongs to negative infinity to 1 included, and then this x belongs to 1 to 4 included, and that x belongs to there's a belongs to and 4 to infinity. That is a wrong Hilbert function. What is the problem? 1 has been included in the first rule, but also included again in the second rule. That's not going to work. And this 4 included in the second one, but it's also included in the third one. That's not going to work either. Okay, so each x values can only be included once in the whole Hilbert function. If you include the 4 into the second one, you cannot include that in the third one anymore. So that must become a round bracket. So the correct way we can do is change my domain like that. And now 1 only in the second one, not in the first one. 4 in the third one, not in the second one. So that will work. Okay, so two things. Okay, first is your domain. You cannot overlap your domain. Okay, cannot overlap your domain. Yep.
So could not including bracket around the 4 including the next one. In x squared
that one? So I'm not include the 4 in this one, but I have included in this one. Which means I take it's not really repeated. It's the last point is before 4, not at 4 exactly. So the point 4 is in this function. When you sub like 3.999, you put in that one. But when you sub 4, you will put in that one. Okay? Okay, so those ones will, even though you're not really have 4 on this function, when you sketch the graph, you still need to find, okay, put 4 in, you have 4, 16, and you draw open circle at that point. Okay, that point is an open circle. That's an end point. You still need to show the coordinates of this 4, but you know that's an open circle, you're not going to include that in. Okay, that's Hilbert function. Okay, let's have a look at the examples. Let's see this example. There are 3 rules in this example, and I have -3 excluded from the first one, but I have included that in the second one. The 3 belongs to the second one, but it's excluded from the third one, which means that's a correct Hilbert function. Okay, the first time means that's correct. There's no problem with that. Okay, the next thing is I'm going to sketch that. So how I'm going to sketch that? You can see this. Their separation points is -3 and 3. Okay, -3 and 3 has separated your graphs into 3 sections. So you don't need to do this. Okay, just for me to show you how it works, so make you feel like more clear to see. So I will sketch a line here at 3, and I will sketch a line at -3. So can see in this I have rule x plus 3 in this section, and I have in the middle part you have x in that section, so y equals to x, y equals to x plus 3, and when it's greater than 3 you have y equals to 1 over that. Okay, so your graph is actually shows 3 different parts. Okay, 3 different parts. Okay, for the first one, I'm going to show x plus 3, where x is smaller than -3. So you need to work on endpoints. Okay, even though we cannot take x equals to -3, we still substitute that in. So when x equals to -3, y equals to -3 plus 3, y will be 0. So I have -3, 0. But I don't really need to draw that. It's an open circle at -3, 0. Okay, that's an open circle at -3, 0. And all the left part will be possible to sketch. Okay, all the left part belongs to x plus 3. So I will put like maybe x equals to -5. Y will equals to -5 plus 3. Y equals to -2. So I'll have a point here, which is a closed circle because I can take that point. And because it's linear, so I can connect them. Okay, I can connect them. I can make it longer. Okay, so I will label 2 points, -5, -2, and I need to label this, even though that's an open circle, is -3 and 0. That function belongs to this section. And let's have a look at the middle section. The middle section is y equals to x with domain -3 and 3, both sides included. So x equals to 3, y will equals to 3. X equals to -3, y will equals to -3. So 3, 3, and -3, -3 is the 2 endpoints. Okay, it's those 2 points here. It will pass through the 0, 0. You know that, right? It passed through the point 0, 0. So I need to label 0, 0 because that's the intercepts. And I also need to label that point is 3, 3 and -3, -3 because that's the endpoints. Okay, let's just take off this straight line here. The graph looks like this. Okay, graph looks like this for the first 2 parts. And for the third part, okay, for the third part, y equals to 1 on x minus 3. First of all, you cannot take x equals to 3, but x equals to 3 is the asymptotes. X equals to 3 is the asymptotes. I'm not really taking that value, but that's an asymptote for me. And also that's a hybrid function, plus 0 at the back, so that is y equals to 0. I'm not extend to that side because I don't have graph on that side. Okay, not on the left hand side. I just have asymptotes at the part belongs to me. Okay, at that section. That section belongs to 1 on x minus 3. So I have x, y asymptotes at that section. Okay, next thing is, I'm not going to write 3, 3 here. I'll write it in this part. Okay, and you know that it will be in the first quadrant and third quadrant. So I can only have greater than 3, so I only have the top part. My graph looks like that. But I need to find 2 points on the graph to make sure where I should sketch it. So let's say when x equals to 4, I randomly put 2 points in. Okay, doesn't matter which you put in. And y give me 1. So 4, 1 will be 1 point. Okay, 4, 1 will be 1 point. When x equals to 5, y equals to 1 on 5 minus 3, y equals to 1/2. So 5 and 1/2 will be another point. Okay, now let's connect them. Okay, that is the graph. So 4, 1, 5 and 1/2. That's the asymptote. Okay, so that is my graph. Okay, that is my graph. Okay, and the 2 linears are parallel. Okay, the 2 linears are parallel because they have the same gradient, 1. Okay, so they are parallel lines. And be aware of that. The -3, 0 is an open circle, but -3 is the closed circle. And 3, 3 is the closed circle. So my question is, when x equals to -3, what is the y value? What is the y value? When x equals to -3? 0 or negative 3? When x equals to negative 3, what is the y value? 0 or negative 3? That's my question. Negative 3. Okay, do not take the 0, so it's negative 3. Okay, so I need to label 2 points on this linear, 3 points on the second linear, and 2 points on the hyperbola, and 2 asymptotes. Okay, so there is nothing different compared to the normal function and hybrid functions, because hybrid function is just drawing the graphs in one set of x-axis, like for like 2 or more graphs drawing on the same set of x-axis. But like the graphs will not overlap. The graphs will not overlap between the domains, so you will have vertical lines. This part of graph only belongs to the first section, second graph only belongs to the second section. Okay, so you just draw them on the same set of axes. Okay, example 2 is another one. We talk about specify the function represented by this graph. We can see that 3 functions on one set of axes. That must be a hybrid function. Okay, that must be a hybrid function. So let's have a look at the first one. The most left hand side, the green one. So what's that should be? What kind of graph is that? Hyperbola. Or actually, I can also say that's a truncus. It doesn't really matter. I can say it's a truncus as well, because I don't see the right hand side part. It can be a truncus, can be a hyperbola, depends on where the second part is. For the second one, what's this? Linear, but this linear with equation what? That's the most easiest one. So y equals to 3. Okay, directly is a horizontal line. And for the third one, what's that? What's that? What's the third one? Quadratic. Okay, and let's see. We have another line separate the graph from here. Okay, we have another line separate the graph from here. So if I say that's fx equals to, okay, we'll have fx equals, let's say that's a hyperbola. We are not going to try truncus. So we have the first equation like that with x belongs to negative infinity to negative 2, but not included negative 2. Okay, I can't take negative 2 on this equation. Second one is y equals to 3. So it's fx equals to 3. X belongs to from negative 2 to the point of 2. Included both ends. Okay, included both ends. And the next one is like a quadratic, ax minus h squared plus k. X belongs to 2 to infinity. Okay, 2 to infinity. Okay, so that's the rules I can write for this hybrid function. But I haven't worked out what is the hyperbola and what is the quadratic. Let's find the rules for that. Okay, that point is 2, negative 2. That point is 4, 0. Okay, for the quadratic, I can say y equals to, remember this a, alright? Every time, like I will see like 10% of the students forget this a value when they write the equations. So x minus 2 squared minus 2. Okay, that's the turning point form, but you must have that a value and you're going to work on that a value. So you will substitute x equals to 4 and y equals to 0 to find out the a value, because 4, 0 is on this quadratic. So 0 equals to a, 4 minus 2 squared minus 2 So 2 equals to 4 minus 2 is 2. 2 squared is 4, so it's 4a. So a equals to a half. A equals to half. Okay, so I can change this rule here now. That's a half x minus 2 squared subtract 2. Okay? So, yep. It's 3, right? Yeah. Too small, that's 3. Well, it's not going to change a lot, so that's a 3. And that will become a 3. So that's 2 equals to a. So a is 2. So that's 2. Yeah, that's correct. That's 2. Yeah, so 2 times x minus 2 squared minus 2. And that's the quadratic. And let's have a look at the hyperbola. We have asymptotes. Where's the asymptotes? That's y equals to 2, and that is x equals to minus 2. Okay, y equals to 2 and x equals to minus 2. So I will have y equals to a over x plus 2 and plus 2. Right, plus the y values and subtract the x values. So it's a over x plus 2 plus 2. And I need to find one point. The point is here, -3 and 0. I can see -3 and 0 on the graph. So I will substitute y equals to 0. A over -3 plus 2 plus 2. 0 equals to minus 1. A divided by minus 1 is minus a. So a equals to 2. So that one becomes 2 over x plus 2 plus 2. And I can write my fx. Write my fx in the middle. Okay. Any question about this? Okay. If no question about this, I want to show you another one. Do you want to still see that? Can you see, like, every Hilbert function we're talking about here, they all have a jump, like at the, there's not connecting, okay, between the two rules is not connecting. I will show you another example now. I want you to sketch, let's do an easier one, okay, let's do an easier one. So fx equals to two functions. Okay, we have this one. Okay, we have this equation. And I want to sketch this. I want to sketch this. No? Oh, that's wrong notation. Okay, so I want to sketch this. So that's a quadratic in the turning point form already, and I can find the turning point. Let me just put this down. Okay, let's say we have xy here. And let's label the turning point first. Let's label the turning point first. So the turning point will be 1 and 3. Okay, the turning point will be 1 and 3. Okay, here's the turning point. And I have my endpoints. The endpoint is 2. Okay, endpoint is 2. So f2 equals to minus 2 times 2 minus 1 squared plus 3. And that gives me minus 2 and 1. So 3 and 2 and 1. You can see that that's a quadratic and turning point is here. Somehow the graph will look like that. Okay, so you will have y-intercept and x-intercept. So let's look for y-intercept first. So which is f0. So f0 will equals to minus 2, 0, minus 1 squared plus 3. And that gives you negative 1 squared is 1. 1 times negative 2 is negative 2 plus 3 is 1. So you have 0, 1 as well. Okay, so your graph is this shape. Okay, it's this shape. Okay, because it stopped at the point 2, 1. Stop at the point 2, 1. And I have 1, 3 as the turning point, and I have 0, 2 as the intercept, and I have 1 x-intercept. So I need to work for x-intercept. So x-intercept is when this equation equals to 0. So minus 2x minus 1 squared plus 3 equals to 0. 2x minus 1 squared equals to 3. X minus 1 squared equals to 3 over 2. X minus 1 can be plus or minus of square root of that. X will be 1 plus minus of that if we can rationalize the denominator. If I can times 2 on both top and bottom, so that's a root 6, but the bottom will be 2. I have 2 x-intercept, but on this graph, I cannot have 2 x-intercept because we lose the right-hand side one, so I only have the left-hand side. Okay, so if you extend your graph, the second half is here. Okay, the second half is here. So I don't have that, so I only have this point. So this point is 1 minus root 6 over 2, comma 0. Don't stop. Okay, so here. Okay, so the graph looks like this. And the next thing is I want to find the linear. Okay, we finished with this quadratic. We have the endpoints labeled, turning point labeled, x, y, intercept all labeled. So it's all good for the quadratic graph. And the next one is the linear graph. Okay, for the linear, we have 2x minus 3. And 2 is the endpoints, but that's an open circle. So when x equals to 2, 2x minus 3 equals to 2 times 2 minus 3 equals to 1. And that equals to 1. So that open circle is 2, 1. Okay, can you see at the point 2, 1 is already a closed circle? Can you see that's already a closed circle? So think about we have a closed circle and we have an open circle around the closed circle. What will happen? The circle will become closed or open? Closed. Okay, so we seems like a round open circle here, but the point is still here. Those two graphs connect together. Okay, those two graphs connect together at the point 2, 1. So you are not going to show open circle anymore in the stage. They are just closed together. Okay, the open one overlap with the closed one. It becomes a closed circle. And then I can have graph, like it's a positive graph, right? So it's roughly that direction. So I need to find another point. I'm not going to have the x-intercept because go up, I won't have x-intercept. So let's make a point 3. When x equals to 3, f3 equals 2 times 3 minus 3, and that gives you 3. Okay, I have 3, 3. Okay, the point 3 is 3, so I'll label 3, 3 here. Okay, that's the shape of this graph. And the point I want to make here is the overlap between the closed circle and open circle become a closed circle. You are not going to show open circle anymore. It's just one notation thing here. Okay, when x equals to 2, why I'm not writing f2? Okay, see this point? Why I'm not write f2 equals to 1? I write 2x minus 3 equals to 1. Because it's not f2, okay? f2 is here. f2 is follow the previous function. It's not follow the second one. So when x equals to 2, if you write f2, you should substitute into the first one, not the second one. Before the second one, I just want to find the open circle. Where's that open circle? It's not on the function f. Okay? It's not on the function f. It's actually, if you write f2, you should substitute into the correct equation, which is the first one. But I also want to see when x equals to 2 what the second function equals to. That's why I directly write 2x minus 3 equals to blah blah blah. I'm not writing f2 equals to that. Okay, you write f2, then you need to substitute 2 into the correct place. Okay. Okay, any questions about this? Okay, 3 examples. The first one is sketching, but like there's a jump between the open circle, closed circles. Second one is we have closed circle, open circle at the same place that overlap to become a closed circle. And the third one is giving you some hybrid functions, asking you to write the rules for that hybrid function. Okay, and hybrid function is not hard. Okay, that's it. So that's it. I'm not going to continue today, so you can do some revisions. And the plan for next Tuesday will be inverse. And then we need another lesson on Thursday to finish up the last bit. Okay.